Hello everyone. In this video, we discuss the Group B or short aims essay type question of the 2023 MAKAUT question paper of, of the subject of the utilization of electric power of the electrical engineering department. So first question is which scheme is generally used for overhead electrification of long distance railway in India? And discuss and question why. In Indian Railways, the electrician midnight service or long distance service, there is a single phase 25 kV and 50 Hz AC supply used. Because there is some advantage of 25 kV 50 Hz AC supply system over the DC system. Because DC system is using tram trolleybus use the DC system, but AC system there is some advantage. That's why we use the Indian Railways electrification. There are some advantage. First advantage is light overhead category because we use voltage 25 kV. So line current is less. That's why possession of area of the overhead conductor is reduced. So small size conductor is lighting, supporting structure, and foundation are also light and simple. That's why we use a light overhead triangle. Next is a less number of substation because since pressure is voltage is 25 kV system, so line current is less and line voltage drop, which is mainly due to the resistance of the line, is correspondingly less, and it improves the voltage regulation of the line. That's make larger spacing, and this spacing about 50 80 kilometers between the substation possible. And against of the 150 volt DC, there is a distance 5 to 15 kilometers, and 3000 volt DC, and this distance without distance 15 to 30 kilometers. The required number of substations along this track is considerably reduced. That's why there is a less number of substations with the less number of substations. And so the substantial saving in the capital expenditure on the track is the leads. Next, flexibility. Larger spacing of substation gives the better flexibility, and its selection of the site for proper location. And this substation can be located near the high voltage grid, and fortunately may run close to the main railway routes. And the substation are fed from the grid, thereby saving the railway administration lot of expenditure for creating special transmission lines or for their substation. Next is simplicity of substation design. In AC subsystem, there is substation are simple in design and layout because they do not have to install uh, uh, maintenance install and maintain rotary converter or rectifier for AC in DC as a DC system. Because in DC system we convert AC to DC, then we supply. So if AC does not require any converter circuit, and the substation only consists of a static transformer along with the associated switch gear, and there's a and directly take power directly from the high voltage national grid. So next point is the lower cost, and this installation portion there is a lower cost of the installation. So including about the DC installation. So this portion there is a 25 system, there is a lower cost. And in AC system, there is a AC motor is a high starting electricity system. So that's why we use the AC system according to the DC system. Next question is that derive the relation between the luminance and luminance of a point light source. So first we know the understand the what is the concept we understand the concept of luminance and illuminance and their respective measurement. First, lumens refer to the amount of light emitted or reflected from a surface in a particular direction and is perceived brightness of a surface and is measured by the unit of the candela per meter square or square meter. And this luminance depend on the source of the light as well as reflective quality because there is some reflective quality smooth and diffuse reflective quality. So depend on the which type of reflective properties of the surface. Next is the illuminance. So illuminance is the amount of light reaching the surface and is measured in the unit of lux. And luminance represent the level of lightning and brightness of a particular location. So next, how to relation. Next is let's consider a point light source radiating light uniformly in all directions. And if assume that the light source is not affected by any absorption or attenuation in space. In this scenario, but illumination at a particular distance, light source will decrease with increase the distance according to the square law. Because in inverse square law, E proportional to 1 by R square. The people, so R is the distance. So according to this law, that illumination at a distance d point light source is given at E proportional to I by 4 pi d square. So I is the light intensity of light source and 4 pi d square is the surface area and whose radius is the d. Means illuminance is defined as the amount of light emitted or reflected for a unit solid and from a surface, and this symbol is made by L. The relationship between the lumens and illuminance is equation L equals to rho E cos theta. Rho is the reflectance of the surface and E is the illuminance and theta is the angular normal vector of the surface and the direction of the incident light. And this equation represents a basic relationship between the lumens and illuminance for a point of light source. But it is important that all the derivations and idealized scenario with the point shows a uniform radiation in all directions. But in real world situation, additional action in shape and size of the light, at present light source, and the surrounding event environment can affect the relationship between the lumens and illumination. So next question is a suburban train runs with an average speed of 36 km per hour between two stations 2 km apart. Values of the acceleration and acceleration are 1.8 km per hour per second and 3.6 km per hour per second. Compute the maximum speed of the train assuming capital speed time curve. And this is the mathematical problem. And this question capital speed time curve means main line speed time curve. So our given data is a first of all when we solve this problem, so any speed there is a value unit is a kilometer per hour, then convert to the meter per second, and any distance is a when given a kilometer, then convert to the meter. So our average speed is the given average speed Va is equal to 36 km per hour. Then we convert the meter per second, the value is the 10 meter per second. Distance between two stations given B is a 2 km is the convert 2000 meter. And acceleration constant alpha is the 1.8 meter per hour per second. Then after the converting, then value is a 0.5 meter per second. The iteration constant beta is value is a 3.6 kilometer per hour per second. Then convert the value is a 1 meter per second square. Then total time is the P is equal to D by average. This dA is the distance by average speed. So value is a 200 second. And there is a concept that K is the alpha plus beta by Q alpha beta. Put the value alpha beta and beta, bring K value, bring the value K value is the 1.5. Then our main objective, compute the maximum speed. So maximum speed Vn is a maximum speed, and there is a formula T minus root over T square minus 4 kT by 2k. Sorry. And this question put the value T, K and D, then value is the 11 meter per second. Then we convert 11 meter per second converted kilometer per hour, then value is 39.6 kilometer per hour. Next question 5. Discuss about the laws of illumination and exposure mathematical analysis. So first law is the illumination is directly proportional to the luminous intensity of the source, or in method of luminous analysis is proportional to I. Next law is the inverse square law. This law states that the illumination of the surface is directly inversely proportional to the square of distance of the surface from the source. So suppose illumination R is the distance of the surface from the source, then in this equation from this law E proportional to 1 by R square. And another law is the Lambert cosine law. This according to law, if E is illumination is directly proportional to the cosine of the angle made by the normal to the emitted surface with the direction of the incident flux. So E proportional to cos theta. And combine this all these factors together, we get E equals to I cos theta by R square. And this unit is the lumen per meter square or lux. And the last question of group B is the compare resistance welding and arc welding. There is some table in following this table. We compare the concept of different features of resistance welding and arc welding. First is the resistance welding. Resistance, there is some point which is the production of heat. Resistance welding is heat produced by the flow of current, mainly contact resistance. And in arc welding, the heat produced the arc heat created between the electrode and the workpiece. Next is the supply. In resistance welding, mainly AC supply used, but in arc welding, AC, DC, both supply is used. Next, requirement of filler material. In resistance welding, no filler material is added for joining two metal pieces. But in arc welding, some filler material means rod is necessary. A proper skin when you obtain a joint. Next, requirement of the external pressure in resistance welding. External pressure is required, but in arc welding, no external pressure is required. That's why it's the simple equipment is simple and easy to control. Next point is the voltage. Resistance welding require very low voltage, but in arc welding, the striking voltage is high. That's why it is very voltage control is very required. Required voltage control. But next one, power factor. This question power factor in resistance welding power factor is low, but this question in arc welding power factor is poor. Next, temperature. In resistance welding process, temperature rise is not very high, but in arc Earth temperature is very high, and if it is not handled properly, it may damage the performance. And another is the suitable essentially is suitable for mass production and also the repair work. But arc welding does only suitable for repair work. It is not suitable for the mass production. Thank you. Next video we will send the other question.